A very good morning to our lecturer, Professor Dr. Joseph Sahaya Anand Tanggaraj. So today we're going to present about torsional loading evaluation from actual structure, and our structure is a screwdriver.
These are the name of the group members. 1. Abu Abbas Azmi bin Abu Bakar. 2nd. Nur Ain binti Zamri. 3rd. Muhammad Fadil Haris bin Tarmizi. 4th. Ain Syahira binti Anas. And 5th. Nur Azza Amira binti Muhammad Nur Bahari. I will continue about the objective for this project. First, to draw detailed FBD from actual structure related to the problem, to study the torsional loading from screwdriver, to develop equation of equilibrium EOE from the FBD draw, to analyze force and member from the structure, to determine the factor of safety used in the structure.
So what is torsional? Torsion is the twisting of an object subjected to torsional load, which is torque, about its longitudinal axis. What is torque? Torque is a moment that causes a member to twist around its longitudinal axis. Just as force is what causes an object to accelerate in linear kinematics, torque is what causes an object to acquire angular acceleration. If the load and direction of the torques acting on an object are exactly balanced, then there is no net torque acting on the object and the object is said to be in equilibrium. There is no net torque acting on a subject in equilibrium. An object will at rest will stay rest, and an object in constant angular motion will stay in angular motion. So, to visualize what I'm talking about, imagine that this is a road, and the cross-section of the road is a clock with just an hour hand. When no torque is applied, the hour hand sits at 12 o'clock. As the torque is applied to the road, it will twist, and the hour hand will rotate clockwise to a new position. Let's say it is 2 o'clock. The angle between 2 o'clock and 12 o'clock is referred to the angle of twist, and is commonly denoted by the Greek symbol of pi. This angle let us determine the shear strain at any point along the cross-section. These are the formula that we use for the calculation. The first is the allowable shear stress. The second is the maximum force that the structure can handle before it fails. And the third is the factor of safety of the structure.
For the dimension of the screwdriver is, the length of the screwdriver is 145 mm, the diameter of the handle is 35 mm, and the diameter of the screwdriver is 3 mm. From our research, we have found that the common material that been used for the screwdriver is the chromium vanadium steel. The material properties is the yield strength is 420 megapascal, for the young modulus is 190 gigapascal, and for the shear modulus is 37 gigapascal, and lastly the shear strength is 540 megapascal. To get the polar moment, we will times the pi over 2 with the radius in the power of 4. For the radius, we will be using 0.0015, and we will get the answer 7.952 times 10 the power of negative 12 meter the power of 4. From the formula of max shear stress, we have calculated the max torque for the screwdriver is 387 Newton meter.
This is our free body diagram of a screwdriver. Torsion has been calculated before. Now, by using the equation of equilibrium, we finally can calculate the force that we have in this FBD. From the free body diagram, we can conclude that total moment equal to 0. By using this formula, we can find our forces. For the force that we have achieved is force equal to 11.06 kilonewton. Finally, we also can calculate a factor of safety. Factor of safety is express how much stronger a system is than it needs to be for an intended load. FOS must be bigger than 1. FOS equal to ultimate stress divided by allowable stress. We can achieve our allowable stress by using force in the free body diagram. Allowable stress that we have achieved is 25.425 megapascal. So, by using the formula of factor of safety, we finally have the result by 21.24.
In this question, as we know, torsion occurs when a shear stress is applied to the body due to the torque. Torque is a moment that twists a structure. Our group chose screwdriver as model in this project. The maximum torque that can be applied to the screwdriver is determined from the torsion formula, tau equal to Tc over J, where tau is the maximum shear stress, C is outer radius, T is resultant forces, and J is the polar moment of inertia of the cross-sectional area. Maximum torsional force also will cause the screwdriver fail. We also develop equation of equilibrium to show the forces act on the screwdriver. A system must satisfy all three equations of equilibrium in order to be in equilibrium, with summation fx equal to 0, summation fy equal to 0, and summation moment equal to 0. By using equation of moment with negative t plus f times L equal to 0, we determine the maximum forces. The shear stress increase as the angle of twist increase. The polar moment of inertia, according to calculation, is 7.952 times 10 the power of negative 12. The polar moment of inertia is a measure of an object's capacity to oppose or resist torsion when a certain amount of torque is applied to it on its specific axis. In our investigation, the stress and strain applied to screwdriver was based on the material used to make screwdriver. Meanwhile, the safety factor for this project shown that the material is safe in this working environment because the result is bigger than 1.
As for conclusion, we were able to determine the deformation of a circular shaft when it was torqued. We also learned how to compute the factor of safety of the object, evaluate on how to do the test to determine the shear modulus of elasticity of material for material. Furthermore, an increase in either the load or the distance from the load to the center will result in an increase in the elasticity shear modulus. We have managed to find the maximum torsional force of the screwdriver, which is 386.99 Nm, and allowable stress is 25.425 megapascal. If the screwdriver working above than 25.425 megapascal, damage will happen. Factor of safety can be determined after that by dividing the maximum shear stress and allowable shear stress, and the result show us that the structure is safe.